We met next with Mr. Timothy Johnson of the Design Division of the Department of Mechanical Engineering and asked him to show us this computer and its Sketchpad.
We're at the TX2 console at Lincoln Lab. This machine is a large computer. It was built by Lincoln Lab in 1956 as a research machine.
Now, how does this differ from a computer that would be used to run your bank account or something like that?
Well, it's designed specifically for a study of manual intervention, where the man can command the computer to take different courses of action while the program is running. We have several unusual pieces of input-output equipment here. We have a scope, a knob. These are unusual at the time, and push buttons, toggle switches. We have several other related devices. This made the TX2 a prime candidate for the Sketchpad developments back in 1961, and it remained a program in this machine, so it would become a coherent partner in graphics, so the man can communicate with the machine.
How do you actually go about communicating with a computer in a graphical sense?
Well, we are using an oscilloscope here, which is much like a TV set, except it's being driven by the computer. In order to get the information into the computer, we have to draw somehow on this display, and we use the light pen. Well, in order to construct a meaningful engineering drawing, we have to have several graphical manipulations. Sutherland's programs can draw straight lines and circles.
Well, that's about what you do in the drafting equipment anyway, isn't it?
That's a very good start.
Right.
In order to do this, we can position this bright spot in the middle of the cross that you notice at a desired location. And we press the button to command the computer to draw a line. It will draw a line from this position, where I am now, to any subsequent position of my light pen. This is much like a rubber band stuck in two pins. One is nailed on the screen here, and the other is at my light pen. So I can position this anywhere I want. Now, I lost tracking there. I moved the pen too fast, and that told the computer to stop drawing the line. Well, if you notice, that bright dot will jump onto the line as I get close to it.
Well, the dot in the center of the cross, when you get close to the line, jumps over onto it.
Correct.
Why does it do that?
It's much like a gravity field. At the end point, it is even a higher gravity field to allow us to position the point exactly on the line, or in this case, exactly at the end point. This allows me to move my pen quite coarsely, be sloppy while I'm drawing, and get a precision drawing out at the same time. So now I'm going to draw a second line.
Yeah.
And even a third one. Now, in an ordinary pencil and paper drawing, all we have is this particular picture. But the computer understands the geometry of the drawing here. What do I mean? I mean that if I point at this particular point and tell the computer to move that point by another push-button command, it will move not only that point, but all three lines that are attached to it.
And the delay between it's doing what you want it to is because it's computing all these changes.
That's correct. Now, if I made a mistake, I could delete my mistake by pointing at the line in question, for instance, and pressing the appropriate button. It's gone. Now, I mentioned before we could draw circles also.
Okay.
In order to do this, I must first indicate the center of my circle. Let's choose it to be here. And then I'll move out to an initial radius, let's say this point right here, and I press the second button to start drawing the circle. Here's our circle. Let me reduce the drawing size so our circle shows on the computer scope. You see, as I move the pen, it is ignoring the radial position. I've just gone off the spoke screen here. The radial position of the pen, and only looking at its angular position. So I can
be very as sloppy as you like.
Right. In other words, the computer supplied the compass here, much like it supplied the straight edge for the straight line.
If you go backwards, you erase it.
And I can wind it up the other way. Now, if I tell the computer to put that point right at this circle, right in that point right there, the computer knows that those must be connected. It turns out that they're not really connected. It's a very small nub there. Let me move this away and show you that they're really not connected. But I have told it by terminating the point of the pen at that position that it must be connected. Now, I can tell the computer to satisfy this constraint command by bringing in a program under command of this toggle, and watch this go. You see now that indeed the circle is ending at that line. We have constrain a drawing to behave this way.
Well, now, I wonder if you'd expand a little more on this idea of a constraint. Just what do you mean?
All right. Let me go to a second piece of paper. Now, what I've done here is I really saved away that drawing I just drew.
Can you get it back again?
I can get it back, and I can select my drawing number by these toggles here. So I've selected a blank piece of paper, we'll call it. We have several pieces of paper. And I can, let's say I'm beginning to design. I have a very nebulous idea what I want to have in mind. Now, as I draw my part, let's say on the scope, it reinforces what I have in mind. This is, in general, part of the design process. And as I apply design criteria, stresses, and so on, eventually I will know what the exact shape of this part is. I shouldn't be required to draw the exact shape at the beginning. I really don't know what it is. But let's say I've decided eventually in this model that I want these to be horizontal and vertical, a box. I can apply a new constraint, a horizontal constraint here, a vertical constraint here, and a horizontal here by pointing at the line and pressing a button. Well, no, nothing has happened yet because remember I still must tickle that toggle over there to command the computer to satisfy these constraints.
So you won't actually let those rubber bands relax then until you say so.
Right. And I'll do that and watch again. There we have a box.
Well, now this idea of having constraints like this, being able to make lines meet or to make them horizontal or vertical, makes it quite a step ahead of something that's just a drafting machine that allows you to draw.
Exactly. In other words, you can get the topology down of the part, and at any subsequent position in your design, you can make it to behave exactly what you want. Straighten the drawing up. In other words, you don't have to draw exactly at the beginning like you have to do in drafting. This is, of course, just one aspect of the program. Now, what I can do, in addition to this, is call up copies of master pictures. Remember that picture we drew before? Mm-hmm. I think it looks something like that. That's right. What I've done is I regard that first picture as a master. Mm-hmm. I call up a copy of it, and I can manipulate it locally. I can reduce it, magnify it, I can rotate it, and let me place it right there. And I can do this several times. This is, of course, very instrumental for repetitive drawings like circuit diagrams or bridge bays, where we have several repetitive structures.
Oh, if you were drawing a circuit diagram, you might have little resistors or transistors or something already drawn and stored away, and you could call up as many of those as you wanted.
Right. Now, imagine that when I was doing my design work, I made a mistake in my master. Well, in order to correct that mistake, I would go back, and let's say I don't really want this circular segment to be in here. I erase it. Now I have the problem of making these changes to all the occurrences of this copy in my working drawing. This is very tedious nowadays. With pencil and paper, we have to remember where all the changes are. Now you notice, you remember the drawing, that we now have lost our circular arcs.
So if the manufacturer, for instance, of some electronic part changed the design somewhere one of these years, you could just automatically change all the drawings in which it appeared.
Correct. Well, now I've showed you many of the basic graphical manipulations we have available.
Incidentally, I would like to ask you how big this piece of paper that you keep referring to is, and how many pieces of paper you have available to you.
Well, this scope, which measures about 7 inches on the side, we regard this as a window that we can move over our paper and enlarge the size of this window. We can imagine the computer has a fixed sheet of paper behind this window. Its scale is approximately 2 miles on the side.
2 miles?
Right, and let's look at that. I can reduce this drawing slightly. And let me call up a copy of that master drawing again. Put it over the center there. Oops.
There.
Now I've hit one stop already.
That's as small as you. You're looking at the whole piece of paper. So.
Correct. And let me magnify it now. And now it's magnified so it's practically off the screen. Place another one in there.
Sort of like the picture within a picture within a picture idea.
Right, it's real nightmare material.
And as it gets smaller, even though the spot sort of disappears, it's really still there, isn't it?
Right, the computer has this all memorized in its memory.